Well, thanks for joining us. Can you tell us a little bit about yourself? Where do you work and what kind of things you teach?
Yeah, for sure. So I'm Omiya Hassan. I'm an assistant professor in the Department of Electrical and Computer Engineering here at Boise State University, Idaho. So I started back in 2023. So I'm fairly new here in the academic line. My research actually focuses on developing energy efficient computer architectures, and the major focus is developing AI accelerators. Like, how can we efficiently run these computations on our computer and hardware and even edge devices, right? So the courses that I teach here are mainly computer engineering and electrical focus. So I teach a very like junior level course such as digital systems, which is very much important in the computer architecture domain. And then I also teach a senior undergraduate and graduate level course, which I created here specifically at Boise State University, which aligns with my research as well as the state of the art, which is Edge AI Hardware Systems course. So that's very much aligned in my domain and research area, and it's very kind of up to date. Yeah.
Well, that's awesome. Thanks. So, where are you seeing current gaps in graduates now in their knowledge when they enter into industry or move from, say, undergraduate into graduate level research? What are those skill gaps you're seeing, especially around edge AI?
Oh yeah. So since again, I'm associated with the Department of Electrical and Computer Engineering, and AI started off as like a very computer science focused field, right? But then because of the memory wall issues, because of the computing needs and the memory needs, I think the focus is now also, and kind of like we're also responsible to know some things about AI, right? We can't be totally ignorant about it, or at least try to understand the basics of how AI is working, what are the computational needs and whatnot, right? So, during my time when first started as a grad student, I had no knowledge of AI. I just knew the word artificial intelligence. I didn't know how to train it. I didn't know what to do with it and what it is, right? And then when I started my PhD, my supervisor said, we have to work on AI and we have to get on on the train because we work where we were VLSI engineers, so digital IC design, and we do a lot of computational needs. We design computer architectures, and we realized in order to design these efficient accelerators, we actually need to know how AI model works. At least try to understand the basics of it, right? So I feel like as graduate students, who are entering into their research field from master's to PhD, should have some knowledge of how AI works. Even though it's a very computer sciencey domain, I still think people, and it's it's like AI model, like learning about machine learning models and AI models, it's so many, materials and courses are out there and very much open source. So, you can just log into Coursera or Udemy or even your YouTube channel and kind of, you know what AI model is, train a model. There's so many libraries out there. Train like, plug in an open source data set and then try to understand what's going behind. And I think that gap is still persistent, especially for international graduate students. And I think people should, start learning and start to know what AI models are or machine learning models are.
Absolutely. And you came up through the traditional doubly or computer engineering track, right? So you learned embedded systems, electronics, all the theory behind that. But I'm guessing they never really touched AI, and that's where you're seeing that gap
Mm,
now, right?
exactly. Yes. Yes.
Got good to know. If you were to design a course or a full curriculum from scratch, where would you see that going? Or if you're working with Boise State now to design that curriculum, how do you see that being integrated and teaching all those AI skills that you just mentioned?
Yeah. So I think the biggest challenge right now in designing such a course is the experience and the level of expertise, right? So
Mhm.
the Edge AI hardware system course that I've developed throughout this year, and I even got funding from the university to develop this course, is that people from different background are taking this course. Background from electrical engineering, computer engineering, even computer science folks, because it's hardware centric as well. So, even though we have a bit of knowledge gap in how AI model works, training an AI model, the math behind it, the architecture behind it, I think computer science folks also need to understand the hardware that is running their AI models, right? What are the architectures? Do I actually need to optimize my model? Why is my model becoming so power hungry? What does power hungry mean, right? So there are different students coming from different backgrounds, and I think that's the biggest challenge, and how we can set the level field so that everybody's on the same page at start. So one of the tactics that I think I kind of developed or in the process of developing is, before even starting the course, in the first introductory, I kind of analyze, like, I sectioned my course into a place where the first module is the CS folks are going to have an easy time, but maybe the computer engineering and the electrical folks might have a hard time, because I talk about a lot of deep learning models, the architecture behind it, the math behind it, how do we train a model, right? What does accuracy mean? What are the evaluation metrics, right? What is a computer vision model? What are layers? What are kernels, right? And then I pair them up. So I pair a CS student with a CE student or a EE student so that they can work together throughout this course. So the second model kind of shifts. Now we're talking about hardware. So now the CS folks are like, oh, what does that mean? What does a processor mean? What does a SRAM mean? What does a DDR5 mean? So I think this helped. I feel like this teamwork helped the to structure the course in a way where, like, oh, I'm struggling, but my teammate knows a bit about it, has the foundational knowledge, so let's work together. Can you tutor me, or can I tutor you, to kind of set the level on the course? Yeah.
I love this idea of cross collaboration and making sure you pairing up CS with ECE students. And
Mhm.
did you say this was a junior level course? What or where are people taking this?
So this type of course is senior undergrad and graduate level course. Yeah.
Got
So
it.
yeah, and the way we set prereq is, if you come from a CS background, then you have to have some knowledge. Like, you have to take courses. We already have like deep learning courses, machine learning courses, and computer vision courses that undergrads take. So those are prereq for the CS folks. For the CE and double E folks, you have to take digital logic design. You have to take microcontroller embedded systems in order to understand what is working on the hardware arena.
You make sure each of the
Yeah,
students have some base level coming in, but their expertise might be a little bit different.
exactly. Yeah.
That's a really cool way to do it. I like that approach is you make sure so you're coming bottom up and then you're pairing up people with different expertise to make sure there's some collaboration going on. Because
Exactly.
what I've seen is Edge AI involves a lot of different fundamental knowledge across a lot of different areas. And I like your approach for this. So are you finding that this bottom up approach is really working? Have you seen things like top down approaches where you might introduce it earlier, say freshman or sophomore, but you kind of black box it away? Have you tinkered with that at
Mhm.
all?
Um, the bottom up approach really works well. I haven't explored the top down approach, and I think if I had the opportunity, I would like to look into freshman people and be like, oh, start from, start looking into these things. And I think in the future, and it's a long way, I just started in 2023. But I feel like snippets by snippets on every course, if we can introduce them from like a junior level or a freshman level, I think that would be really helpful and intuitive for sure.
Got it. So like a spiral style curriculum where you
Yeah,
hit it throughout the courses individually, maybe using some black box tools like Edge Impulse or
exactly.
whatever it might be.
Yeah.
And then as you build up the more fundamentals, you can come to this, kind of, and it's not a capstone course. What are you calling your course for the
It's
seniors and
it's
graduates?
actually an elective course. It started as a special topic. So the fun fact about tenure track assistant professor is that you get to make your own course that aligns with the research. So that was my special topics course, which was very popular, and it got really good student evaluations and student enrollment. So what they did was they integrated into different programs. So now it's in the ECE bachelor's, ECE graduate studies, and we have a program called PhD in Computing. And in the PhD in Computing, what is it? It's an entity on its own, and what happens is it's run by the Department of Computer Science and Math, and collaborators such as the ECE or any other co-ed like College of Engineering departments. And what this PG in computing is it has different type of emphasis. So emphasis in data analytics, emphasis in math, and then we have something called emphasis in AI. So this course got integrated into that as well.
Oh, that's great to hear. So where are you seeing the hardware side of this come in? Because you mentioned that your expertise and your research area is in developing these accelerators. Are you integrating that into the course at all and having people develop their own accelerators, use them, explore them? Or is it all just, hey, let's train and deploy to embedded systems just because that alone is pretty difficult?
No, actually, I introduce hardware. So one of the modules is going from back end to front end. So what I do is, for example, the first thing I do is when I shift from the software side to the hardware side, in between software hardware, for example, I take an AI model and I say, now we have to map it in hardware. So great, we are mapping it in hardware, but there's a problem in a processor. There's a problem in memory. Let's look at the processor design. What type of designs are we doing? We're doing parallel computation. We're doing systolic arrays. We're doing MAC tree operations. So now we're getting very hardware centric. We're actually looking and picking up logic blocks and saying, oh, we're not just doing traditional arithmetic logic unit or ALU unit. We're doing multiply accumulate, and that's a completely different architecture than a traditional CPU. So, what does Google's TPU look like? What does NVIDIA's, say, GPU look like? And we look at the architectures. And then we do something called, and then I teach them what roofline plotting is, right? So, is it compute heavy? Is it memory heavy? How are, like, now we're now very much into the hardware domain things. And one very special thing about Boise State is that a lot of research efforts is going on AI computation and AI acceleration. So I have these invited talks. For example, I invite people from the neuromorphic domain. I invite people from the photonics domain that are working with AI or trying to accelerate AI. They come here, they give talk on their research, which are very hardware centric, but their application is common, which is AI. So now we're kind of diving into the hardware parts of things. Another thing that I did in the past two courses was um, we did some edge AI lab based experiments. So I took a microcontroller and then I told them this is the memory, this is the compute power. You need to design which is kind of like the AI deployment session where now they trained a model, they optimized the model, and they inferenced it on the microcontroller, did some kind of application. But then in the microcontroller, they're kind of seeing, okay, so this is how I'm mapping it, and this is the optimization issues that I'm having, or the architecture within, like, how is this doing the computation? What is the architecture behind it? How are they designing the processor? And stuff like
No, that's great to hear. So that sounds like a really good senior or graduate level where you understand the fundamentals going into it. So then when you get to describing things like multiply and accumulate
that.
and all the individual blocks, they actually have a really deep understanding of what's going on in the hardware. And hopefully it
Exactly.
prepares them if they want to go off and research and, design their
Exactly, yes.
own, but they're at least capable of using those accelerators going into the field or going into industry. So that's really exciting to hear. And I love the idea of cross collaboration. That's such a cool idea, and to bring in both CS and ECE and collaborate, because edge AI is such a broad field, and trying to get everybody together and having somebody understand everything that's needed to get to that point. So that's a really great
Exactly,
approach.
yeah. Exactly. And I think, in industries, I just had some experience as an intern, working at a company during my grad school. And what I've seen is that people from different fields come together and create a team. And sometimes the person who understands all the different fields, like way of talking, like for example, W majors talk technically in a very different way than CS majors, right? And that's just the tradition. That's just how it is. That's how the field talks about. Even the way we talk, say evaluation metrics or accuracy, people see it very differently. Like if I say resource utilization, I mean it in a hardware perspective way. Maybe in a CS, they would say resource utilization in a completely different way. So if you work with someone with a different major, then you'll understand their language, their technical language, and that helps the students, flourish in industry, right? Or flourish in whatever setting they want to be in.
Yeah, that's a great point. And I like how you're preparing them and thinking about the future for preparing these graduates for what industry is going to need. So if you don't mind, if we can pivot for 5 minutes, and I know this is a whole new can of
Sure.
worms, but I'd love to know how you are working with or dealing with AI being used in education at large, so things like
Mhm.
LLMs and ChatGPT. How are you seeing that being used in your courses? Are you disallowing it in your courses, or are you encouraging uses? Because I find that it's a great shortcut for a lot of engineering things, but it sometimes prevents you from understanding the deeper concepts, especially if you're trying to learn something new. So I'm really curious your thoughts on that. And I know my audience has a lot of interest in AI in education at the moment. So what are your
Mhm.
thoughts on how AI and things like ChatGPT are being used?
Yeah. So I think, one of the things that I believe in is that we shouldn't have like a one hard policy for everything. Like for example, different type of AI models or LLM models or like ChatGPT, Claude, Gemini is being used. In some cases, like for higher courses, like AGI hardware system courses or like senior level courses or graduate courses, maybe using those tools will accelerate, will be beneficial for them because we are now targeting a higher level problem or challenge that we're facing. So yes, maybe forgetting, oh, I forgot how to write this set of Python code or this set of JavaScript, but my goal is completely different. It's much more higher. So maybe using ChatGPT or using Gemini or using Claude would be beneficial so that I can achieve the bigger goal. Right. And that's for like higher level courses. So I encourage higher level courses to, even like search for good articles or journal papers that they want to propose or they want to present or they want to work on. But I also have the chance of taking like junior level courses like digital system, right? And these are like fundamental courses that builds the student for becoming a successful electrical engineering or computer engineering. So in those cases, the good thing is that for EE and CE majors, I think LLM models have not yet found the solution for all the problems that we give them. Like they give like really erroneous problems or like they generate like a mistake. They don't really still doesn't understand Boolean algebra or the algorithm that goes into digital system, which is good for me up till now. Like even if students are using LLM models at the back, they also know that that's the wrong way of that's kind of the answer that they're giving is wrong,
And
right?
you can spot it right away if a student's using one. Yeah.
Exactly, yeah, because my exactly, because we're like EE and CE courses are very problem-solving courses. We don't have to write much. We just have to do a lot of math, a lot of logic, and a lot of physics into it. And I think the students also know that using these doesn't come, handy. So for me, I had the privilege of not using it for the junior level courses. Um and I think for academics, we also need to adjust the way we design our courses since students are using LLM. We can't just tell them to stop using it if academic doesn't want it. I think we have to redesign our courses into a way where students are actively learning the fundamentals or the foundation, doing coursework or giving them works where they don't have the opportunity to use LLM, especially in junior level or early stages of undergrad studies. So I think it's both ways, right? So the teacher has to the academic or the instructor has to develop a syllabus in a way where if they are not comfortable using LLMs or comfortable making students use LLM, they have to restructure the course in a way that like motivates to not use it right now in the early stage. And maybe in the future, like in the more senior level courses, try to give them a instruction manual on when to use these type of models or what would benefit them on which places they'll use it and what would not benefit them if they use the LLM model in that.
So do you see it much like a calculator, but at a higher level where,
Yeah,
early
yeah,
math tests, you do it by
exactly.
hand?
Exactly, yeah. I think in like I don't know, like in a 5th grade, I think in 10th grade, 5th grade, we weren't allowed to use calculators, but now I use calculator like almost every day, and then that's fine, right?
So it's just a
So
tool you learn to use, but you have to demonstrate a grasp of the fundamentals before you can move
exactly.
on to being able to use the tool and trust the tool, or in this case, know when the tool is wrong because they hallucinate. These LLMs are not perfect.
No.
All right, last question. Do you have any advice for instructors or professors creating this curriculum, and at that junior and senior level, how can they start introducing LLMs? You mentioned a couple of good opportunities, such as, search for papers, write this boilerplate Python code that I just forget
Mm.
how to do the syntax, but you have done it
Uh-huh.
before. Are there any
Mhm.
other tips or techniques you'd like to leave listeners with about how they might go around integrating LLMs?
Like LLMs, like using LLMs in their work, or like, yeah.
Yeah, not training or making.
I think for, I mean, the best advice is kind of like, what do you want to get out of it? Right? Do you want to take the easy path and become a shallow learner? Or do you actually want to make LLM a tool for you so that you have more knowledge or can be more in depth? Right. So you can write an assignment, complete an assignment, or even create a full course structure by giving the accurate prompts or the right prompts to the LLM. But that won't benefit you in general. Right. So, for example, I feel like first start yourself. Like, even if I wanted, for an instructor, if I want to design a course, the first thing I do is start myself. Like, I have my own ideas. So I'll align them. Maybe they'll be messy, but then I'll use LLM to organize them. So kind of like, that's my organizer, right? Or maybe I would be like, oh, give me some references or give me some ideas that would improve my course, but the foundation should always come from within us, right? So it can be from doing your assignments, doing your homeworks, to even an instructor level, reviewing a paper, or like even, you know, um, writing something, generating ideas, designing a course. It should first start from us, and then LLM can be a tool or an assistant that can kind of polish it.
Yeah, good answer on that. And then I'm assuming you would say the same if you were to flip that to the student side as well, where the
Yeah,
students should demonstrate an understanding of the fundamentals, show me you know these first principles
exactly.
before moving on to using them as tools. And that way you can check the work, right? So it all comes down to the
Exactly.
first principles or fundamentals of knowing what's going on.
Exactly, yes. And one thing I would like one advice I would give for the students is that if the students used any type of LLM model in their work, the instructors can identify it and they know it. Like, I think the instructors have like that level of understanding of which student is using an LLM and which student is not using an LLM. So you can't really bypass an instructor of how they use it or how they not use it.
I am curious about the work being done to have LLMs identify work done by other LLMs. I think that's fascinating.
Yeah, that's fascinating, but I also don't trust that as well, because I've been working with LLM models for quite a while to know that we don't have the best of the best plagiarism detector or the LLM detector, because an LLM is being used to detect an LLM. So
If you can't trust one, how are you going to trust the detector to detect the detection? Like, oh my goodness.
yes, exactly. So yeah.
That's great. So thank you so much for your questions and your time here. I think you had some great points for this. I'll let you know when it goes live. And I want to thank you for your time, Omiya, and thanks for joining. I look forward to seeing you in person at ECEDHA.
Yeah, me too. Yeah, see you on March 20th then.